Hi, I'm sure you heard about machine learning or deep learning, but do you know what are the problems that machine learning can be used on? Machine learning is not a silver bullet. Typically, it is used to solve 4 problems. In the next few minutes, I'll show you the 4 problems, and after the video, you would be able to talk about machine learning like a pro. So watch to the end of the video. Problem number 1, prediction or regression. In this diagram, x-axis represents YouTube advertising cost and y-axis represents sales. If we can find a formula or a model to proxy the relationship between advertising cost and sales, then if we want to double or triple our advertising cost, we can use it to predict our sales. The aim of regression is to predict the value of a dependent variable based upon other explanatory variables. There are simple linear regression like this one, and there are other complicated nonlinear regression like this one. Problem number 2, classification. Can you classify these pictures into dogs and cats? Of course you can. Machine learning can do it too. The aim of classification is to split data into 2 or more predefined groups. Another common example of classification is spam email filtering, where emails are split into spam or not spam. Problem number 3, clustering. Suppose you are the CEO of Amazon.com. You could be, maybe in the future, who knows. How do you segment your customers into different groups so that you can provide better service and products to each different group based on their different needs? This is a clustering problem. The aim of clustering is to split data into smaller groups or clusters based on certain features. The difference of clustering and classification is, in classification, we have predefined categories. You know how many categories, you know its categories, dogs or cats, but in clustering, we don't know. We need the algorithm to help us find out what are the groups. Problem number 4, dimensionality reduction. The process of machine learning is to use input variables to calculate an output. Among all the input variables, which ones are the most useful one? Maybe some of them are just noise and should be removed. Dimensionality reduction is a technique to reduce the input variables in a dataset so that the algorithm can be faster and more accurate. If we could reduce a 3D problem into a 2D problem and into a 1D problem, that would be a lot easier. You could say dimension reduction is a step in machine learning, but it is very important. Let's put all of them together. You know, there are many algorithms in machine learning. In order to choose a good algorithm, you need to be clear what the problem it is. Is it a classification issue, or we need to use regression and prediction? Or it's a clustering problem? Or maybe we need to do dimension reduction first. This choose algorithm roadmap is from sklearn. If you want to put machine learning into practice, write some code, this is a master check. I'll leave a link below. Let's summarize the 4 problems: prediction or regression, classification, clustering, and dimensionality reduction. The next time when you talk about machine learning with other people, you could say, hold it, what's the problem? It is a classification issue. No, we need to do dimension reduction first so that we can do clustering. That will make you sound like a pro. If you like this video, remember to subscribe my channel or give me a thumbs up. Thank you.